Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning programs. This is Teacher Pasco, and today I will be with Senior 2 chemistry students, starting a new unit, and that is unit number 7, the mole concept and gas laws. And today's lesson is the introduction to mole concept. Here we will define what a mole is, how is it used in chemistry, why is it necessary to use this mole, and the relationship between this mole and other quantities we use in chemistry. And before we go deep in the lesson, let us have a look at the objectives, what we should know at the end of this lesson. At the end of this lesson, you should be able to define a mole and define molar mass. What is a mole? What is molar mass? You should also be able to determine the number of moles and corresponding mass for various particles. We will look at this in details. And number 3, you should be able to determine the number of particles in a given number of moles. So these things, the 3 objectives will be, the 2 objectives, the second and the third, will be focusing on the calculations, some simple calculations we can work out in this unit we call mole concept. So, what is a mole? Before I explain what a mole is, there are some questions I want to ask you. We know how people like to call various sets of items different names. You remember that, you know that. How do we call a set of 12 items? What is the name given to a set of 12 items? What is the name given to a set of 500 papers? The papers we use for printing, for example, the foolscaps. How do we call that set? We know so many different sets which have particular names. For example, when we say a week, you know the number of days in a week. When we say a decade, you immediately understand the number of years we have in that period. So when we say a set of 12 items, we call this one a dozen. And when someone says, I want a dozen of this or that, you immediately understand the number of those particular items the one wants. When we say 500 papers, you remember, we call it a ream of papers. And it is the same with this idea of mole, the mole concept. A mole is a set of particles, a particular number of particles. Just like how we call a set of 12 items, we give a particular name to the set of 30 days, 12 months, and we call it a year. It is the same as how we take a particular number of particles, the particles which can be atoms, which can be ions, which can be radicals, which can be molecules, and we call that specific number of particles a mole. But why is it necessary to have this mole in chemistry? Do you remember how small an atom is? We said that, and we have seen that, atoms are very small. Now imagine if you have to carry out a reaction. Let's say you have sodium reacting with cold water. How will you determine the number of particles that are reacting in your reaction? It is not something very easy. Why? Because of the small size of atoms. And because of this, it was very necessary to find a way of relating the mass of reactants to the number of particles reacting. And what I can call a bridge of those two, the mass and the number of particles, is what we call a mole. So if you have, as I said, if you have, for example, a dozen of cups, you know the exact number of those items in that set. So if you use, like, let us say you use or you buy 4 cups, then you can immediately determine or deduce the number of cups you have bought without going into complicated calculations. There is no need. You know that 1 dozen contains 12 cups. So if you buy 4, you can deduce the number of cups you have bought. And for example, if you know the exact mass of 1 dozen, then from the mass you can determine what? You can determine the number of dozens, and from that number you can determine the number of cups. So this is how scientists dealt with this challenge of knowing the number of particles that are reacting. From that relationship between the mass and the number of particles, what we have called the mole, we can determine the number of reacting particles from the mass. So let's say we have a mole. A mole which contains a fixed number of particles and the fixed number of particles which has a fixed mass. Fixed mass. So from the mass, you can determine the number of moles. And from the number of moles, you can determine the number of particles, the reacting particles. So it is something very clear that the mole was really needed. That quantity we call a mole, the number of particles. Now, we are saying that a mole is a set of particles having a particular number. And what is that number? The number is here. A mole is a set of particles containing exactly 6.022 times 10 power 23 particles. I repeat, 6.022 times 10 power 23 particles. So in a mole, we have that number of particles. Number of particles is 6.022 times 10 power 23 particles. Here the unit of a mole, I said it is a quantity, and its unit is MOL. We use MOL, that is mole. And scientists determined the number of atoms in 12 grams of carbon-12. I'm saying carbon-12 because, as you know, we have what we call isotopes. There is carbon-12, there is carbon-13, there is carbon-14, and the common one is carbon-12. So when scientists analyzed or measured 12 grams of carbon-12 and try to determine the number of particles in that mass, they found that we have 6.022 times 10 power 23. This number is called the Avogadro's number. See, the number is called Avogadro's number, and it gets the name from the scientist who determined it, who is Amedeo Avogadro, the Italian scientist. So, you can see from this number of particles and the mass of carbon-12 that there is a relationship between the mass and the number of particles. And that is the reason why for 1 mole of a given type of particles, we always have a fixed mass, a defined mass. And how do we call that mass? We know that for a given atom, we call its mass the atomic mass. For a given molecule, it will be called molecular mass. And for a given mole, it will be called molar mass. So it's molar, the fixed mass, which is molar mass. The molar mass can be determined in different ways. You can calculate it, but you can also use your periodic table. And how do we determine that from the periodic table? Look here, please. It is being said that 12 grams of carbon-12 are found to contain 1 mole of particles of carbon-12 atoms. This Avogadro's number is symbolized by Na. So if you look on your periodic table, you find that the mass of this carbon-12 is 12. And when we express this mass in common units, we find that 12 grams, exactly 12 grams of this carbon-12, the number, this 12, which is the same as the mass number of our carbon, but here the difference is the unit of mass, which is in grams this time. We find that this mass contains 6.022 times 10^23 atoms of carbon-12. So there is a certain relationship here. For magnesium, for example, which has 24 as mass number, then if we take the same mass in grams, we will find that this mass contains 6.022 times 10 power 23 atoms of magnesium 24. It is the same with other elements on the periodic table. What is the atomic number of iron? It is 26. And the mass number, I hope you have your periodic tables. The mass number is 56. So 56 grams of iron 56 contain 6.022 times 10 power 23 atoms of iron 56. So if you read the mass number on the periodic table, you will find that that number, the mass number, when converted in 2 grams, when considered in 2 grams, it will be containing 1 mole, that Avogadro's number, of the atoms of that particular element. Now, let us see how we determine the molar mass. But here we have something which is written on the slide. The mass of 1 mole of a substance is called its molar mass. We said that. For 1 mole, then it is the mass of 1 mole, it is molar mass. And here the units will be grams per mole. Mass of 1 mole, so it is grams per mole. So here we are saying 56 grams, then this is 56 grams per mole. This is the molar mass of iron 56. For magnesium, 24 grams per mole. This is the molar mass of magnesium. Okay? Good. And here we have some examples. For aluminium, the mass we read on the periodic table, it is 27. So the molar mass is that reading from the periodic table expressed in grams per mole. Sulfur, we have 32 grams per mole. Chlorine, it is 35.5 grams per mole. Okay? Here you have to be very careful. Sometimes, remember, we can have diatomic elements. So if you consider the molecules, then the molar mass may double, will double. Relative atomic mass. What do we call relative atomic mass? I hope you remember this. Relative atomic mass, the mass we read on the periodic table is called relative atomic mass. Atomic mass, it is because we have the atom, but why is it called relative? You can imagine how it is possible to measure the mass of those very tiny particles, the atoms. And because of this, because of being very difficult, scientists invented a way of building or constructing a scale, a mass scale, to which we have, or in which we have, a standard element, and the standard element which is used as a reference, then which can be considered as a point of comparison when determining the masses of other atoms. And this element is carbon-12. Carbon-12 is the standard element which is used to determine the masses of other particles simply by comparing. So that is the reason why you call it relative. It is relative to that mass of carbon-12. For example, when we take carbon-12 and you measure the same volume of carbon-12, which has 12 grams, the same volume of magnesium, you find it to be having 24 grams. And what does it mean? When you compare, you find it to be weighing double of carbon. And because it is double, then here you will deduce that the mass of magnesium should be 24. Because when compared, you find that of these particles to be double of carbon-12. If you have a particle X and you find it to be weighing 3 times greater than carbon-12, then you take 12 times 3, because it is 3 times, and this one will be having, or will be X36, like that. I think it is very clear. So from there, here we have the example. If magnesium 24 has 24 grams, it means that for the same number of particles, magnesium weighs twice the mass of carbon-12, which is very clear. Now, what is molecular formula and molar mass? Molecular formula, we know that. We have the elements, but when elements or atoms from different elements react, we get molecules and compounds. And the symbolic representations of those compounds or molecules, that is what we call molecular formula. For example, here we have a molecular formula of sodium hydroxide. This is the molecular formula of sulfuric acid, aluminium oxide, and iron oxide. So when you have an element or an atom, 1 mole of an element, you can determine its molar mass. But when you have a molecule, one mole of molecules, you can determine the molecular mass or the molar mass of that substance. When you have 1 mole of a molecule, what will be the mass of that mole of molecules? How do we work it out? You just sum up the molar masses of the atoms we have in the compound. Example, here we have sodium hydroxide. What is the molar mass of sodium? It is 23 grams per mole. Oxygen has, do you remember the mass of oxygen? It is 16, because we have 1, and for hydrogen, it is 1. And when we add, what do we get? We get 40 grams per mole. So 1 mole of sodium hydroxide has 40 grams. Example number 2, H2SO4. For hydrogen, we have 2, so it will be 2 grams. Sulfite is 32. We read this from the periodic table. And oxygen is 16 times 4. Then we get 98 grams per mole. Very simple. You can try these 2 examples as your exercise. We have an exercise here. A group of 6.022 times 10 power 23 particles, which may be atoms, ions, or molecules of a substance, is called, how do we call that one? You will complete that sentence. And 1 mole of carbon dioxide contains how many atoms of carbon? We have 1 atom in 1 molecule of carbon dioxide, so how many atoms will be present? The mass of 1 mole of nitrogen atoms is equal to, remember, it's nitrogen atoms, not the molecules, and remember the unit of a mole. And here it is mass of 1 mole. And then mole is a link between what and what. You will try this exercise. We go to the next slide and see some of the calculations we can carry out in this mole concept. Of course, there will be some simple calculations because we are just introducing. It is very simple to calculate the number of moles. Examples, the number of moles, you can get the number of moles when you use the formula we have here. You can start with the given number of particles. Let us go back to the example of items in a dozen. If they say you have 48 particles, for example, 48 cups, what will be the number of dozens if you know that a dozen contains 12 items? That you get the total number of items over the number of items in a dozen, and you get the number of dozens. Very simple. The number of moles can also be calculated if you use mass. We have the total mass of particles, and we know the molar mass of 1 mole of particles. You can get the number of moles. As well, you can get it when you use the mass of a molecule over the mass of the molecule. Mass of molecule in grams per mole, so you have molar mass and the mass of molecule. And here we have the example. As we are used to this, the second one will be done as your exercise. Calculate the number of moles for this number of helium atoms. We have the number of moles. The number of moles here, it is N. which is equal to the particles we have, that is 12.044 times 10 power 23 over 6.022 times 10 power 23. And how many moles do we get? You can see this is double of this one, so we get 2 mole. In that example, we have 2 moles of helium atoms. The second is for your exercise. Calculating the number of moles, second example. Calculate the number of moles in 54 grams of aluminium. How do we do it? We have the mass, so it is 54 grams over the molar mass, which is 27 grams per mole. And you get still 2 moles. And for the second, it is very simple. You will apply the formula and work it out. Calculate the number of moles in 4 grams of sodium hydroxide. Number of moles when you use 4 grams, so it is 4 grams over the molar mass. Molar mass for sodium hydroxide, it is 40 grams per mole. 40 grams per mole. And what do we get? We get 0.1 mole. So these are some of the examples showing how we can determine the number of moles. We will get more examples. This is an introduction. And you will try the homework we have. The homework we have here is, we have 6 questions. It's for your good. You will try all of them. Calculate the number of particles in 0.1 mole of carbon atoms. Number 2, calculate the number of moles in 12 grams of oxygen gas. And number 3, calculate the mass of 6.022 times 10 power 23 nitrogen molecules. Here you have to take into consideration this. Nitrogen molecules, it's not atoms. Remember, nitrogen molecules, they have 2 atoms. Distinguish between N2 and 2N. 5, calculate the mass of particles in 0.5 mole of nitrogen molecules. And the last, what is the mass of 0.5 mole of water molecules? The exercise is very simple. We are just introducing, and we will get more exercises. Let me hope that you will take time and work it out. Thank you very much for your attention. I hope to see you next time for the next lesson. Stay safe.